Okay, now we move to solving problems in this chapter, consumer demand and consumer choice. The first problem, given the following table that shows different quantities of magazines and books with their corresponding total utility. Price of magazine is $2 and the price of a book is $5. So the price per magazine is $5 and is $2 and the price per a book is $5 and Ahmed, the consumer, has $33 to spend on both goods, magazines and books. What combination of both goods would maximize Ahmed's utility? Of course, here the very first thing is that a table is given and then we have to fill the missing in the table. Of course, usually in a question like this, he will give you the number of units in each good and the total utility. And all you have to do is to find the margin utility and the margin utility per price for each good. So in this over here, the total utility is given, okay, and you have to find the margin utility for magazines, and you have to find the margin utility per price, and of course the total number of units of books are given, and then the total utility also for each unit of books is given, and you have to do, or you have to find the margin utilities, okay? So now, as you can see, if the total utility are given for each unit of magazines, the margin utility is easily found. As you can see, for the first unit is 50 units, this total utility, it is the same as the margin utility. Now, here, in order to find the margin utility for the second unit of magazine, all we have to do is, do the formula, which is, the margin utility for the second, unit is equal the change in total utility over the change in the quantity. So 90 minus 50 over 2 minus 1. So 90 minus 50 is 40 over 1 is 40. Now, the margin utility for the third unit is going to be equal 120 minus 90 over 3 minus 2. 120 minus 90 is 30. Over 2 over 1 is going to be equal 1. So 30 over 1 is 30. The same thing for the fourth unit is going to be equal 130 minus 120 over 4 minus 3, so it's going to be equal 10. Now for the fifth unit, 132 minus 130 over 5 minus 4, which is equal 2 units, and then 132 minus 132 is going to equal 0 over 1 is going to equal 0. This is the margin utility. So the margin utility per price, all we have to do, divide the margin utility, each number over here, by the price of magazines, which is equal to. So we get here 50 over 2 is going to 25, okay? 40 over 2 is 20, 30 over 2 is 15, 10 over 2, of course, is 5, and 2 over 2 is 1, and 0, of course, over 2 is 0. Great. Now we move to the finding or filling the missing columns, which is the margin utility and the margin utility per price. Here we do the same thing as we did in the magazines. So the margin utility for the first unit is equal to 30, 300 minus 0 over 1 minus 0, 300. The margin utility for the second unit of books, the second book, is going to equal 500 minus 300 over 2 minus 1 is going to be equal 200. The margin utility for the third unit is going to be equal 600 minus 500 over 3 minus 2, 1 is going to be equal 100. 650 minus 600 over 4 minus 3 is going to be equal 50. 675 minus 650 is going to be equal 25 over 1 is 25. 680 minus 675 is going to be equal 5. So then we need to find the margin utility per price. We do the same thing as we did here. So we divide by the price of books, which is 5. So 300 over 5, 60. 200 over 5 is 40. 100 over 5 is 20. 50 over 5 is 10. 25 over 5, 5. And then 5 over 5 is 1. Now, in order to find the combination of magazines and books that will maximize Ahmed's total utility, we need to make sure that two conditions are satisfied. The first condition is that the marginal utility per dollar is the same for both goods. The second condition is that the total expenditure on the units of each good, okay, is equal to the total income. So let's start here. So we do the first marginal utility of magazines over price of magazine should equal marginal utility of books over price of books. So 20 equal 20, that's good. Now we say 20, as you can see here, 20 is equal 20 over here. Great. This 20 corresponds to what? To 2 magazines. And the price of magazine is $2. So 2 times 2. This is the expenditure on magazines. Now, here 20 corresponds to what? To 3 books. Each book, costs $5. So we get here 3 times 5, 15. So 3 times 5, 15 is plus 4, we get 19. But 19 is less than 33. So here, not accepted. So we do what? We check for the second one. We try another one. So now we do this one. 15. Do we have 15 here? We don't have 15. 5. Do we have 5 over here? Yes, we do have 5. So marginal utility per magazine over price of magazine should equal marginal utility of books over price of books. So 5 equal 5. Great. Now, here 5 corresponds to what? To 4 units of magazine. The expenditure on this is going to be equal to 4 times 2 will be 8. Plus, here 5 corresponds to 5. 5 times 5, because the price of a book 5, each book 5, and we consumed here 5 books, therefore 5 times 5, so we get here 33. So which is equal to the income of Ahmed. Therefore, here we say, we stop here and we say that the combination of magazines and books that maximizes his total utility is, 4 magazines and 5 books. That's great for this chart, for this equation. Now move to problem 2. Problem 2 similar to problem 1. Same thing, similar. The same techniques we use here in problem 1, we're going to use in problem 2. In problem 2 below is a table showing different combinations of 2 goods, X and Y, and their marginal utilities. So in this equation, or in this problem, he is giving you the marginal utilities instead of the total utilities. And you have to find the total utility. Great. Now, price of X per unit is $2. Price of Y is $4. Great. So this is the units of X from 1 to 6. He is giving you the marginal utilities. Now we need to find the total utility. How we find the total utility of X if the marginal utilities are given? So we say for the first unit, the marginal utility is the same as the total utility. So 20, 20. Now for the total utility for the second unit is equal to the total utility for the first unit plus the marginal utility for the second unit. So what we do, we have to add here, we have to add 20 plus 18 will be 38. So now the total utility for the third one is we need to take 38 here plus 16, the marginal utility here, you come up with 54. Now the total utility for the fourth unit is that 54, we calculated here for the third unit, plus 14, we come up with 68. Now, to find the total utility for the fifth unit, 68 here, plus 12. 68 plus 12 will become 80. This is the total utility for the fifth unit. Now, to find the total utility for the sixth unit, we just add 80 plus 11, we get 91, and this is 91 is the total utility for the sixth unit of X. Okay, now to find the marginal utility per price, all we have to divide the marginal utilities here that are given by the price of X. So divide by 2, 20 over 2, 10, 18 over 2, 9, 16 over 2, 8, 14 over 2, 7, 12 over 2, 6, and 11 over 2, 5.5. So we finish from here. We move to, of course, the units of Y. The units of Y is giving you total utility. Find the marginal utility. It's very easy. Marginal utility is the change in total utility over the change in quantity. So we get here, of course, 48, okay, to come up with the marginal utility for the first unit is the same as the total utility for the first unit, okay? His total utility when he consumed the first unit of Y is 48, and his marginal utility is also 48. Now to find the, the marginal utility for the second unit is going to be equal 88 minus 48 over 2 minus 1, which is 40. To find the marginal utility for the third unit, we get what? 124 minus 88 over 3 minus 2, we come up 36. To find the marginal utility for the fourth unit is going to be equal 156 minus 124 over 4 minus 3, we come up with 32. To find the marginal utility for the fifth unit of Y is going to be equal 180 minus 156 over 5 minus 4, we get 24. To find the marginal utility for the sixth unit, which is 12, is going to be equal 192 minus 180 over 6 minus 5, and we come up which is 192 minus 180 over 1, which is equal to 12. And now what you do, we just divide to find the marginal utility per price when the price of Y equal 4. All we have to do divide the marginal utility. Okay, here we calculated each one by 4 to come up with the marginal utility per price of Y, and we come up with this 48 over 4 we get 12, 40 over 4 we get 10, 36 over 4 we get 9, and all the way until you complete the calculation. Okay, so this is when the price of Y equal 4. Now we complete the missing columns. This is what we did. Now we move to part 2 of the problem. If the income is 22, now income is 22, what is the combinations of X and Y that maximizes total utility? We do the same thing. Two conditions must be satisfied. The first one, the marginal utility per dollar is the same for both goods. The marginal utility of X over the price of X should equal marginal utility of Y over the price of Y. The second condition is that the expenditure on the goods, on the units of X and Y should equal the income of that we have, which is 22. If the expenditure on the goods equal the income, then we start and we say the combinations, and we find the combinations of X and Y that maximizes his total utility. So now we do the same thing. Answer. Okay, two conditions are here. Okay, marginal utility of X over price of X should equal marginal utility of Y over price of Y. 10 equal 10. Great. Now, 10 over here corresponds to 1 unit of X. The price of X is what? It's 2. So 1 times 2 plus. Here, 10 corresponds to what? To 2. 2 times 4, 8. We get 10. Okay? So that is wrong. Try another one. We'll try another one. Marginal utility of X over price of X should equal marginal utility of Y over price of Y. So 9 equal what? 9. 9 here equal 9 here. Great. But okay, that's good. Now we do see the expenditure on this. 9 here corresponds to what? To 2 units of X. Each X, cost how much? 2. So 2 times 2, 4. Plus. Here, 9 corresponds to 3. 3 times 4, we get is 12. 12 plus 4 gets 16. Still, is not equal to 22. Therefore, you have to try another one. Try another one. We move to this one. Margin utility of x over price of x equal margin utility of y over price of y. So we get here 8 equal 8. Great. Now, 8 corresponds to 3. 3x, 3 times 2 plus 8 corresponds to 4. 4 times 4, 16. And the total of this is equal to 22, which is equal to the income. So we stop here. So now we say the combination that maximize total utility are, 3x and 4y. Simple as that. Now we move to part 3 of the problem. Find the combinations of x and y if the price of y decreased to 2. Price of y now decreased to 2. And income and the price of x are the same. So income is 22 and the price of x is still 2. And the price of y now becomes what? 2, because decreased to 2. So in order to, simplify the problem, okay, now what we do, we build another column, okay, about the margin utility per price when the price of y equal 2. Now here is the same. The margin utility of x over price of x the same, no change in this, because the price of x is the same. However, the margin utility of y over the price of y, it changes from this column to this column, because the price of y equal 2 now. So now we have to compare this column 4 with column what? 1, 2, 3, 4, 5, 6, 7, 8, 9. So compare column 4 with column 9. Okay, so what you do now? The same thing. We say 10 margin utility of x over price of x should equal margin utility of y over price of y. 10, we have 10 here, we don't have 10. 9, we don't have 9. 8, we don't have 8. 7, we don't have 7. 6, we have 6. So 6 equals 6, great. Okay? 6 equals 6, great. Now 6 corresponds to what? To 5. 5 times 2 plus 6 here corresponds to what? 6 corresponds to 6 plus, 6 times 2. So 6 times 2, 12, plus 10, 22. Therefore, the combination that maximizes total utility are 5x and 6y. Simple as that. Now we move to part 4 of the problem. If income decreases to 10, now income decreases to 10, and price of x equal 2, price of y equal 4, what are the combinations that maximize total utility? The same technique, okay? Now, here, price of x, no change in column 4 and column 8, because here, when the price of x is equal to, and here, when the price of x equal 4, okay? Only income changes. So now we have to compare. Start from here. The two conditions. You try to implement the two conditions. Margin utility, the margin utility per price is the same for both goods. So margin utility of x over price of x should equal margin utility of y over price of y. This is the first condition. We'll do here 10. We have 10. Okay. Here 10. Okay. 10 equal 10. Now 10 corresponds to what? To 1 unit. So 1 times 2 plus. Here 10 corresponds to 2 units of y. 2 times 4, 8, plus 2, 10. So the two conditions are satisfied. Great. So now what you do here, therefore, the combination of x and y that maximizes total utility are 1x and 2y. So this is basically, these two questions are similar, okay? Once you solve the first one, you will be able to solve the second problem. It just, follow the methods that I have already discussed in this chapter, that in order to prove, or to find the combination of the two goods that maximizes a consumer's total utility, all you have to do try to work with the two conditions. The two conditions we have already discussed must be satisfied, and then once they are satisfied, then you don't have to go further. If you compare the first one and it works, the two conditions are satisfied for the first try, then don't do the other. We move to problem 3. Still we are in the solving part of problems. Problem 3, of course, he is giving you a graph where you have, an indifference map. Remember, an indifference map consists of many indifference curves plus a budget line. This is a budget line. So you have two goods, X and Y. X is along the horizontal axis and Y is along the vertical axis. You have the budget line where K is the Y-intercept and L is the X-intercept. Now, the question, of course, this is the graph that you have. You have an indifference map, many indifference curves, are above each other, and then you have a budget constraint. Which curve is considered to be unattainable? That is, the consumer is unable to reach it based upon his income and the prices of the two goods. Of course, as you can see, the indifference curve IC3 is unattainable because it is above the budget line. It's above the budget line. So his budget dictates, which, of course, indifference curves he can reach. So this is because it's above the budget line, therefore it is an unattainable indifference curve. Now, which point is inefficient? Of course, as you can see, A and B, point A and B on the budget lines are attainable. However, are they efficient? No, they are not efficient. For a basket to be efficient, it should be in the highest indifference curve that is tangent to the budget line. So A and B, could be, it's better, to be efficient, they have to be on the highest or on the higher indifference curve, the higher indifference curve that is tangent to the budget line. So because they are at a lower total utility, because A and B are located on a lower indifference curve. They are located on IC1. And IC1, of course, constitute a level of utility that is lower than the level of utility that is located in IC2. And so, because of that, we say A and B are inefficient, are not efficient. Okay? B, as a matter of fact, is efficient because it's located on the indifference curve IC2 that is tangent to the budget line KL. Okay? Now, which point maximizes utility? Of course, as you can see, point B maximizes utility. Why? Because it is the point of tangency between the highest indifference curve, in this case IC2, and the budget line. So it is efficient and it is, a maximizing point. Now, given an income of $1,000, so the income of the consumer here is $1,000, and PX, the price of good X, is $200, and the price of good Y is $500. Find points K and L. Points K and L. Remember, the easiest way to find K and L, where K, as you can see, is the Y-intercept of the budget line, and L is the X-intercept of the budget line. K and L can be calculated easily by using the formula, where K, okay, the y-intercept is equal income over the price of y, the price of the good along the vertical axis. Okay, L is the same thing. L is calculated by using the formula, which is income over the price of the good along the horizontal axis, which is the price of good X. So we do that. As you can see, of course, here is telling you the income is 1,000. So to find K, we say income over price of Y. Income over price of Y, which is 1,000 over 500, we get 2. Now, to find L, L is equal income over the price of X. So L, income over the price of X, 1,000 over 200, we get 5. So these are the values of K and L. Now, calculate the slope of the budget constraint. Of course, the slope of the budget constraint, as we did in the discussion of this chapter, the slope is determined by the ratio of price of X over the price of Y. In this case, of course, because the budget line is downward sloping, then the value of the slope is negative. Therefore, we have negative 2 over 5. So Px over Py minus Px over Py, and we come up with minus 2/5. Now, problem 5, it says Omar's budget constraint for consuming cakes and juice is defined by 2QC plus 4QJ equal 40. The formula like this indicates to you that the price of cake is 2, the price of juice is 4, the price per juice is 4, and the price per cake is $2, and the income is 40. This is the way the equation is written, indicates that this 40 is the income, 4 is the price of juice, the price per one juice, and 2 is the price per one cake. Great. Where QC is the quantity of cakes and QJ is the quantity of juice. Now, part 1 of problem number 5 says at QC equal to 12, the marginal utility of cakes is 10 utils. At QJ, quantity of juice equal 4, marginal utility mu, marginal utility of juice is equal 28 utils. That's 28 utils. 28 utils. 28 utils, of course. Okay, 28 utils. Great. Now, the question, is Omar maximizing utility? Of course. For utility to be maximized, remember that the marginal utility per dollar for both goods should be equal to each other. That is, marginal utility of cake over price of cake should equal marginal utility of juice over price of juice, as we did in the discussion of this chapter, just, in the previous video. Of course, now we put that in the formula over here, as you can see. Okay, we put a question mark over here to see whether they are equal or not. And we plug the formulas, marginal utility of C, of course, he's telling you a dash, marginal utility of C is 10 utils, we bought 10. Price of C is here 2, 10 over 2 is equal, and we have a question mark whether it is equal to the other part of the equation or not. And then we get here, 10 over 2 is 5, is less than 7, which is 28 over 4. When we substitute marginal utility of juice, it's going to be equal 28 over 4, the price of juice, and we come up with 5 less than 7. Therefore, Omar, because, we don't have an equality, we do have an inequality. Therefore, Omar is not maximizing utility. So, Omar is maximizing utility whenever we have an equality. We have an equality. In other words, we have the marginal utility per dollar for both sides should be equal to each other. In this case, they are not equal to each other. Therefore, Omar is not maximizing his total utility. The question, what should Omar do to maximize his total utility? Total utility. Of course, remember, the marginal utility of C over price of C is less than, as we did over here, less than marginal utility of juice over price of juice. So Omar, the prices, as you can see, are fixed here. He's telling you the price is 2 of cakes, the price of juice is 4 fixed. So the only way for Omar to maximize his total utility, in other words, to reach consumer equilibrium, okay, is by adjusting his consumption of cakes and juice. So what should he do in order to go back to equilibrium, or maximize his total utility? Of course, here, of course, since marginal utility of C over price of C less than marginal utility of juice over price of juice, he should decrease the consumption of cakes. When he decreases his consumption of cakes, then what happens? The marginal utility of cake will increase. Remember that more consumption of a good, it means more total utility, but less marginal utility. And less consumption of a good means what? It means less total utility and more, marginal utility. So in this case, we say Omar should decrease his consumption of cakes, and as a result of doing so, his marginal utility of cakes will increase. Okay, and also he can do the following. In addition, he can, increase his consumption of juice, and by doing so, when he increases his consumption of juice, it means the marginal utility of juices will decrease. So here, what you do: marginal utility of cake increases, marginal utility of juices decreases, and they will continue to do this until they become equal to each other, and then until equilibrium is reached, or equality is reached. When equality is reached, then we say that the Omar is maximizing his total utility, that is, he reached consumer equilibrium. Okay? Now, say that, question number 3, say that Omar's consumer equilibrium is represented by the following graph. This is the graph, as you can see, where along the vertical axis you have cakes, quantity of cakes. Along the horizontal axis you have quantity of juices. You have, of course, a budget line. Of course, the y-intercept is k, the l-intercept, or the y-intercept is k, and the x-intercept is l, of course. And then you see here the data, as you can see, 12 here is a number of units of cakes that are consumed along the budget line U1, along the indifference scale U1, and then you have 8, as you can see, units of cakes and 6 units of juices are located at the, of course, at the indifference scale U2, where that indifference scale U2 is tangent to the budget line KL. So now it's saying this is the graph that you have. Based on this graph, can Omar consume 12 cakes and 4 juices? In other words, can Omar consume 12 cakes and 4 juices? Perhaps 4 juices over here. If you go down here over here, something like this here. If you go down here, up to here. Okay? If you go a straight line from 12 all the way, you get 4. Can Omar consumes, as you can see the question, 12 cakes and 4 juice? Of course, 12 and 4, as you can see, are located along the budget line. So his budget line, of course, dictates that he is able to consume 12 and 4. No big deal. Yes, he can. However, is he maximizing his utility at 12 cakes and 4? No. Why? Because 12 cakes and 4 juices are located on a lower indifference curve, which is at U1. And U1 is not tangent to the budget line. Okay? So, 12 and 4 are, inefficient. They are not efficient. To be efficient, they should be located on the highest indifference curve, or on an indifference curve that is tangent to the budget line. So 12 and 4 are located on a lower indifference curve, which is U1. Okay, therefore, even though he can consume them, but they are not efficient. Now, so 4, at what quantities is Omar maximizing his utilities? Of course, Omar is maximizing his utilities, that is, he reaches consumer equilibrium at the point of tangency between the an indifference curve and the budget line. So here at point 8, you see A is located at what? At the indifference curve U2, which is tangent to the budget line KL. So here is the quantities that Umar can consume, and as a result he maximizes his total utility, are 8 and 6. Why? Because are located at the indifference phase, at the indifference curve, which is U2, that is tangent to the budget line KL. Now, 5, find the values of K and L. Of course, as we stated here in this question 3, K and L, of course, are calculated by using the formulas that K, which is the y-intercept, is calculated by using income over the price of, cakes, which is along the vertical axis. And L is calculated by using the formula, which is income over the price of the good along the horizontal axis, which is the price of juice. So when we do that, we come up with, K, as you can see, is equal 40 over 2, where 40, as you can see, is the income. Here, 40 is the income, okay? And then the price of cakes is going to be equal to, so 40 over 2 is equal 20, and L equal 40 over 4, okay, the price of juice, and we come up with 10, and these are, of course, the values of K.